morning, dear students. We are discussing in a previous class about the derivations of kinematics equation with the help of calculus method, as well as we have also discussed the derivations of kinematics equation by graphical representation. So today we are going to discuss about relative velocity. That is a very important concept and very technical concept, that is relative velocity. You please write down relative velocity. So what does relative velocity means? We'll discuss today. We all know what is velocity, all these things we have discussed earlier. So we'll come to know today about relative. What is actually relative means? That means comparisons. Okay, you're comparing with some other terms. Okay, if you're comparing with some other object, then that is the relative. Okay, so relative velocity is what that this term relative velocity is used when we are finding the velocity of an object with respect to another object. Am I clear? When we find the velocity of an object with respect to another object, that means you can write the velocity of an object, the velocity of an object, the velocity of an object with respect to another object. Am I clear? So this is, in short, we can say that relative velocity, the velocity of an object with respect to another object. That means you are comparing the velocity between two objects. As I told you, that comparison, that is relative. Have you got it? See, suppose I am standing in a bus and you are standing in a bus. My bus is also running, your bus is also running. If I compare my velocity with respect to your velocity, then that will be the relative velocity of me with respect to you. Okay? Now in this class we will try to understand this concept with the help of so many examples as well. So you write down this topic, that is relative velocity, the velocity of an object with respect to another object, then this term is used. Let us come to the topic. Suppose we have got two objects. Two objects means, suppose here it is an object for you, that is object A, and this is object B. Let's be very clear in this case. We have considered here two objects, object A and object B. Now, this object A is moving in a velocity 10 meters per second. Understand? The velocity of the object A is 10 meters per second. Velocity of the body B, suppose 20 meters per second. Sorry, it is suppose 15 meters per second. So this is the object A, this is the object B. This is the velocity of object A, that is 10 meters per second, and this is the velocity of object B, that is 15 meters per second. Now in this case, if this 10 meters per second, this velocity 10 meters per second of the body A is with respect to ground. That means if I ask you that what is the velocity of the object A with respect to ground, that is 10 meters per second. That means 10 meters per second is the velocity of the object A with respect to ground. And 15 meters per second, 15 meters per second velocity is the velocity of the object B with respect to ground. Remember, Ground means suppose I am the object A, my velocity is 10 meter per second. Now the observer who is at the ground, that I have considered as the ground. That means with respect to ground, with respect to the place where I am standing, the velocity of the body should be 10 meter per second. You remember that this velocity 10 meter per second is with respect to ground. Clear? And this is also with respect to ground. But if I ask you what is the velocity of the body A with respect to body B, and what is the velocity of the body B with respect to body A, that will be relative velocity of the object A and object B. Now in this case, if object A see the body B, then we will find that object B is moving at 5 meter per second. That is most important point. Once this object A will see towards the body B, object B, he will not see, he will not, think that this object is, he will not find that this body is moving in 15 meter per second. Since this body is moving towards together, A is also moving, B is also moving. Remember, these are moving bodies. Okay, so A is also moving in the same direction. B is also moving in the same direction. That is the important point. Object A and object B are moving in the same direction. At that moment, 10 meter per second is the velocity of the body A with respect to ground. 15 meter per second is the velocity of the body B with respect to ground. But once this body A will compare with body object B, then what A will find that this body B is moving in 5 meter per second velocity. And what does B will think? The B will find that this body is moving with minus 5 meter per second. Understand? Okay? This body is moving with, A will think that this B body is fine, that this body is moving at 5 meter per second, and B will find that this body is moving at minus 5 meter per second. That means we have got now two velocity or two types of this. One is with respect to ground and one is with respect to each other. That means 15 meter per second is the velocity of the body B with respect to ground. 5 meter per second is the velocity of the body B with respect to A. And that means, and similarly, this is 10 meter per second is also with respect to the ground, and minus 5 meter per second with respect to body B. Have you got it? This is, that means now we are comparing the velocity between two body, object A and object B, who are moving in the same direction. Understand? With different velocities. Now for the time being, if I consider two object, and objects are moving with a uniform average velocity, the body is moving uniformly with an average velocity of VA and VB. Suppose we have taken two objects A and B, and this is PA and this is PB are the average velocity of that two body which are moving uniformly. Am I clear? So you can write, let's consider two body or two object who are who has gotten who are moving uniformly and whose average velocity is PA and PB. Understand? PA and PB is the average velocity of that object we have considered. Now if I consider at time t is equal to 0, at time t is equal to 0, when the time t is equal to 0, the positions of the body A will be, you write, at time t is equal to 0, positions of the body A will be what? XA 0. What is XA? X means position. Okay, we have given the position xa0. What is this? It is the positions of the object A when time was 0. Similarly, positions of the body B at time t is equal to 0, then it will be your, you can write here also, I am writing this side, this is x a0 is the position when the time was 0, and xb0 is the positions of the object B when time was 0. Is that clear to all of you? So again, let us discuss these things. This is the PA is the average velocity of a body which is moving uniformly, and PP is the average velocity of the body who is also moving uniformly. When at time t is equal to 0, I have considered that the positions of the body A is xa0 and positions of the body B is xb0. Clear? Now we can write. Now after time t is equal to t, after time t is equal to t, that means this times your time has come from 0 to t, time has changed from 0 to t. You can write after time t is equal to t, the positions of the objects are, as you can see that when the time was 0, this is the position, and after the time t, what will be its positions, we can easily find it out. So I'll try to find here only that this will be like that. So after t time, the positions of the object it will be xat is equal to, at t time, how many displacement it will cover, how many distance it will cover, how many displacement will cover at the time t. So it's very simple. Initially it was xa0 plus distance, that means as we know that distance is distance will be can be found by velocity into time, that is what is the velocity of the body was pa, this is pa into time t. This is the displacement covered by the body A in t time. Have you got it? So this is the initial position plus total distance covered will be the position at t time for the body A. Similarly, for the body B, that we can write this is xb at what time? At t time. This is going to be your xb. This is initial position, and total displacement covered in t time, that you can write as xbt. Am I clear? You can cover the xbt. This is the not xbt, this is velocity pbt, velocity into time. Am I clear? So let us have, this is number 1 and this is number 2 equation. If you don't give a number, then it's okay. No need to give a number for it. You just simply understood it. Okay? Let me repeat these things. What is PA is the average velocity of a body that is moving uniformly, and PB is the average velocity of the body B that is also moving uniformly. When their time was 0, position was xa0 and xb0 for the object B. After t time, the positions of the body is going to be like that. Xat, this is xa0, that is initial position, plus how many displacement it has covered from time 0 to time t. That means from time 0 to time t, it has covered a displacement of pat. This relation has come from the velocity in time, from the definitions of velocity. As we know that velocity is equal to displacement by time, so displacement will be velocity into time. Is that clear? Now if you want to find out the next thing here, that this is the amount of displacement. Okay, this is the amount of displacement, and this is the amount of position. This is position, and these are the amount of total displacement. So if we write, you can write now the total displacement. Now total displacement from A to B. What is this? XAB means total displacement from A to B. This is written as like that: total displacement from A to B. At what time? At time t. At time t. Okay. Now at time t, total displacement from A to B. That is, if I write BA, that means what? The total displacement from A to B. Now we'll find out how many displacement has been changed in time t from A to B. Remember, B to A is not B to A. It is B to A means it is reverse. That is from A to B. From A to B will be measured as, or can be found as, how can we find it? We can find it XBT minus XAT. Like that you can find out. Am I clear? So this is total displacement covered by the object in t time from A to B. Okay, how many displacement has been changed in t time? So once we find the changing in displacement, then we can find the velocity as well. So these things if I put here, what is this XBT means? XBT means this part, XBO plus VBT plus VBT. Is that clear? Minus of XAT. This is XAT, and this is plus, so it will become as it is plus minus of VAT, minus of VAT. Is that clear to all of you? So this is the value of XBT. I have put it plus, so it has become minus obviously. So this implies, if I arrange them, so this is XB0 minus XB0 minus XA. It is XB0, this is XA0, okay? It is XA0. Yes. So this XB0 minus XA0 plus this is PBT plus PBT minus VAT. Clear? So if I write this time, I can find that XBO0 minus XA0 plus, that is PB minus PA. PB minus PA. So what I have now got that, as you can see, this is PB minus PA. How velocity has changes when we find the displacement from A to B. Once we find the displacement from A to B, the velocity has changes from B to A. Is that clear? This is the amount of velocity. That means velocity has been changing from PB to PA, PB minus PA, when we found the total change of displacement from A to B. Understand this case? That means in this case, what this A will see, the object A will see that the velocity has been changed, PB minus PA. Is that clear? That means once this object A will see that how velocity has been changing, that velocity is changing from B to A. Is that clear? As you can see that this is B minus A. So I can write now that PBA, that means velocity of, this is PBA. So PBA will be equal to, I can write PB minus PA. Velocity of B related to velocity of B relative to A. How can you express? This is PB minus PA. you write down this line. Velocity of object B, velocity of object B relative to object A is Vb minus Va. Am I clear? Similarly, you can write, similarly, velocity of object A, velocity of object A which relative to object B can be written as VAB. VAB is equal to VA minus VB. Is that clear? VA minus VB. These things you please note down. Understand? This is quite separate. Let me give a mark here. Yes. Have you understood now? Okay. So this will be what? The velocity of object B relative to object A. It is VB minus VA. Again I am telling, velocity of object A relative to object B is equal to VA minus VB. That is how we represent. Okay, and this all where I think you have understood. You go to practice. So this is simply the expressions of relative velocity, but relative velocity is not comes to an end only in this topic. It is a long topic. Okay, gradually we'll come to know once we discuss briefly types of relative velocity. All this thing we'll discuss, but it is shortly the about relative velocity. Basically, these expressions to remember. Okay, and how we say all these things. And secondly, definitions of relative velocity is also important. I told you that once you find the velocity of a body with respect to another body, then this is the relative velocity. Understand now? I hope you have got it. And next class, there are some graphical points of this concept. We'll try to overcome it. Thank you so much.